issue. Okay, now it works. So my name is Răzvan Gornea. I'm an associate professor in the physics department, and I'll be briefly describing our programs in the physics department, and tell you a little bit more about physics and career opportunities. And I'll then maybe take your questions, see what interests you. If you have questions for me, I'll be glad to answer. Okay, so why doing physics? So physics, it's fundamental science. So basically, you have physics in all fields of science and technology. So our program will give very broad quantitative training, problem-solving oriented, lots of maths, lots of fundamental sciences, and obviously physics. So I just wanted to show this slide, that you have physics in your everyday life. For example, a GPS satellite system requires to know physics for all the people that were involved in building it and operating that system. Then you have all the aspect of research in academia. So for example, here I'm showing a detector. This is a dark matter search detector here in Canada, installed at Snow Lab, close to Sudbury. So it's here in our province. This is a very large particle detector installed in Europe, and we have Canadian participation to this project, as well as here at Carleton. This is called Atlas. It's one of the major detectors installed at LHC, the Large Hadron Collider, which is the highest energy particle accelerator in the world. Here you see an image. So this detector, it's huge. It's like a building. So all these little dots here are actually people to scale. So basically, you see here a picture from inside the detector. So the inners of the detector have been removed. So here you see like the coils that generate the magnetic field. So it's an enormous detector, and it requires the participation of thousands of institutes with many thousands of people. The other aspect, for example, physics is involved with medical applications. Medical physics can be for therapy or can be for improved scanning. And there's a reason why I chose these fields of physics, particle physics, medical physics, is because we have very significant contributions here at Carleton. So we're a very research-oriented department, and we have 3 units. We have a very strong particle theoretical physics group, a particle experimental physics group, and a medical physics group. So I'll talk some more in details. But what I want to say is that if you do physics here at Carleton, you're going to have a very, very useful, very broad training, and it will allow you to go and, for example, either follow an academic path or go work for the high-tech industry. So we're very proud because we are a department which are very research intensive, and we actually offer many opportunities to our students, and I'll talk some more about it. So we offer summer internships and the honors project, which are very important occasions for the students to get exposure to the experiments, to real world physics research, and this allows them to make good choices for their future careers. As I said, we do particle theoretical physics, and We actually have the largest particle theoretical physics group in Canada, and we also do experimental, and we have involvement in many major international experiments, like collider physics with Atlas, and many rare event searches like dark matter searches and neutrino double beta decay search, which happened in an underground laboratory, and we are affiliated with Snow Lab, which is a major installation here in Canada. And due to the proximity and the fact that this is a very important lab, we're very proud to collaborate and participate to the experiments that go to this facility. And it's very important for us, the link to the Snow Lab. On the medical physics side, I have colleagues that work on imaging, therapy, as well as the development of new sensors like biophotonics, which is the future of medical investigation and diagnostics. So I just want to say a few words about what it's offered. So in terms of possibilities after graduating, so we just wanted to show some examples, like the region around Ottawa. It's has many high-tech industries, so there are many opportunities in the industry. There's also various national or government-run laboratories. There's the NRC, Canadian Space Agency, various nuclear safety commissions, and there's still a little bit of nuclear reactor development in Canada. And then there's the international world in the US. So you could, for example, work for NASA or any of the newest space exploration companies. And obviously the medical physics, the medical fields with various instrumentation developments, either in the medical therapy or medical investigation, or actually just research like gene research and pharmaceutical developments. There's also like two major labs in Canada, Triumph on the West Coast and Snow Lab here in Ontario. But there's many labs in US. There's possibilities to work in various applications, or let's say be more general about the contact to the physics world, like for example just teaching or being a science journalist. There's obviously an academic path which will require graduate studies. And if working in medical physics, there's the possibility to work in close contact with hospitals and research centers, and, as well as different other fields. Like for example, many of people that have done theoretical physics might choose a career, for example, in finance, developing different software for the financial world, economic models, and things like that. Okay, so what exactly are we offering here in physics? So we have multiple streams. We have a very hands-on, concrete applied physics program. This is geared toward learning a lot about application of physics, and with the idea that you target more the industrial high-tech corporative domain. So essentially go work for a high-tech industry as a physicist that will make contributions mostly to the research and development branches of that specific industry. It could be lasers, it could be medical equipment, optics, various advanced electronic silicon, solid state, device development, etc. Then we also have our main core program, physics. So this is experimental and theoretical streams. The difference here, so both are like our main program. So most of the students join one of those. The experimental program has more accent, an accent on the labs, whereas the theoretical program will cover more the mathematical. We will have more maths courses and just look more toward the theory. We have an astrophysics program which will add advanced courses in cosmology, astrophysics, astronomy. So if this is something which is of interest to you, you have the option of this stream. We have two combined streams. One is biology and physics. The other one is chemistry and physics. This is for the students that keep an interest toward the other sciences and well, in particular, for example, chemistry and physics can lead into a wide array of new technologies and very interesting and modern fields that have seen lots of industrial and economical development. Like, for example, lithium ion and different type of other batteries, different chemistries for batteries. And we all know there's a tendency to switch toward electrification, and this requires batteries and many other physical chemical systems. So there's actually quite a large demand for researchers and scientists in this field. Biology and physics, obviously, it's very much linked to the development of sensors and instrumentation for medical in the medical field, and this is also something which is very active with many developments, and it's a very dynamic field. And we have a double honors. This is a very intense program. So basically, you get 2 degrees, one in mathematics, one in physics. If you really want to do theoretical physics, but in the same time you love maths and you also want to do maths in depth, then this is the program for you. But it's a very intense degree. We have a major and minor, and there is another program, an honors engineering in physics, but this is given by the engineering department, because once you graduate, you become an engineer. So you do lots of physics. This exists, it's a possibility, but it's not done by us, by the physics department. So you'll have to contact them. It has different requirements, and it has really a structure which is geared toward engineers. Okay, so I just wanted to mention very fast, like the differences. Like, for example, applied physics. So all courses in the first year are the same for all the streams. So in the beginning, you get introduced to physics and maths. Math being the language of physics, so it's very important. You have to set the basis first, and it's only in the second and third year that you start to specialize. Okay, so this has 2 consequences. One is that you can change your stream if you change your mind after you came to Carleton. And in particular, if you do it in the first 3 terms, it actually has no impact on your way forward. Okay, so basically, you have the same courses no matter which stream you are. So you have this flexibility to actually change stream until, I would say, mid-second year. It is possible to change after that, but it's preferable to see the undergrad advisor to basically make a schedule for how we're going to take the courses. There are prerequisites, so there are different connections between courses. So you would like to get some advice how to proceed in that change, but it is possible to do it later. So basically, how are the stream differentiating later? So here for the applied physics, I'm just showing you do electronics, 2 courses of electronics, modern applied physics. So this instrumentation, all these techniques that you will need, for example, in industry, lots of computation, and obviously lots of advanced labs. If you go for the core courses, well, you do more statistical, advanced thermodynamics, mechanics, quantum mechanics, and also lots of labs and programming. I mean, everybody's doing programming. Programming is very important. Obviously, you do that even if you choose a theoretical branch of physics or experimental simulations, data analysis. It's all important skills that you require as a future physicist. Uh, Obviously, you do much more maths in the theoretical stream. And for example, in astrophysics, well, you do these specialized courses started at the last term of the third year. You do cosmology, astronomy, astrophysics. And as I said, if it's something of interest for you, the stream is available. I think this is quite unique in the province. Um, yes. Um, as I said, the courses in the beginning are shared by all the streams because it's all about the basis. And starting in the second year and the third year, now you do the more advanced classes and you start to specialize. The fourth year, it's heavily based on advanced specialized courses. And in particular, if you are one of the experimental branches, you will do the honors project. So what's the honors project? Well, the honors project, it's an advanced lab, but it's different from the other advanced labs in the sense that you're not doing a series of experiments, but you get an immersion into a real research group. So you have to look for a professor that will offer a project to you, and you will join a research group at Carleton. It can be done also at other universities, like for example, University of Ottawa. But basically, the idea is you will join that research group and you will have a contribution. So you get to learn how is to do research, real research, um, and you will also experience that. See if the type of physics that you want to orient your career toward, it's something that indeed you want to do for the longer term. Um, yeah, we have many labs, so this is very important. Now with COVID, many of those labs in the last 2 years were done remotely, but next year we're going to start with regular programs. So this is very important aspect of our program, the fact that you have a very heavy, very important constituent of lab courses. So you actually do lab courses um, from the first year to the last year at various stages, various levels. So we have these programs that essentially many opportunities for the students to work during the summer. So ideally, these internships should be supported or can be supported by various grants, including, for example, the USRA. USRA, it's a grant from NSERC, which is the grant agency in Canada. It's very prestigious, which essentially allows you get paid to work 4 months during the summertime with a research group. Um, if you don't get that scholarship or that grant, um, there are still opportunities because the research group will hire undergrad students to do research during the summertime, which is a fantastic opportunity. So the way it works is that, well, this starts usually after your second year, because you have to be, you know, to have done the basics math and physics courses to be able to contribute to a research project. But the way it works is that in your second year, you already start to meet various professors, so you can interact with them and inquire if there is any research project. They will talk to you about what they are doing, what their research group are doing, the problem they are facing, the problem they are trying to solve, and basically see if you can get engaged with that process and find a project where you can contribute. And if that happens, then depending on the grant availabilities and how each project is organized, they could hire you for the summer. Obviously, if you get a USRA or there are other opportunities. There are private associations that will provide research grants. So you're invited to apply for those projects, and as I said, they are very prestigious. So basically, if you get an award of this type, it allows you a high degree of flexibility in choosing your project because you already have the financial component covered. So, but what's important, my message here is that you have the opportunity to have immersion in a research project. So basically, you have the opportunity to try to experiment with different type of physics. And actually, many of our students will do a little bit of particle physics or theoretical physics or try a medical physics program. And this way, they have a good idea of how it is to do the type of physics that they are interested in. So here I'm just showing a couple of projects in the recent years. So dark matter, particle physics, medical physics, and theoretical subjects, if that's what interests you. Okay, so there's also the same thing happens for the fourth year project. As I mentioned before, there is a significant pace difference between summer internship. So during the summer, you really work full time. So it's much more compact. It's 4 months, but with 2 weeks vacation. So basically 3.5 months, but you work every day. Whereas the honors project, it's 1 year. There's the possibility to get half of honors project, but that's not so optimal because it's very short term. But basically, most of the students, they will do a 1 year full honors project, and they will work about half a day per week for that year. Okay, so there is also the possibility to do a call program. So a call program, it's an underground program which is mixed with working terms. So this only happens starting in the second year. So basically, your first year it's a standard year where you just study. But starting the second year, you have the possibility to do the summer as a work term, and then it continues the same, and it starts in the fourth year. You really have the opportunity to take the full year as a work. What happened is that because you do these work terms, your program get extended a little bit. So most students will finish in 5 years. It also requires you to work during the summertime. It's optional. You could extend it even further. The advantage here is that essentially, if you're thinking about a career in a high-tech industry, or so essentially if you're thinking working after your graduation, then this is a great opportunity because it allows you to experiment various projects. So all the work terms can be taken with a different company or with a different project. So basically, you can diversify and see many opportunities. And most students in the core program, by the time they finish, they graduate, they essentially know where they're going to go. They get hired immediately because you have seen. So let's by the end of your degree, you have enough experience. So basically, you see what you want to do, and also you the company or the project or what you're working at, they have already, like, they know you, they know how you work, you have started the collaboration, and basically there's huge opportunities to get hired immediately right after the program, the study are over. So I would say this is the advantage of the core program. If you're thinking about theoretical physics, math and physics, if you're thinking about an academic career, then maybe the core program is not optimal because what happens here, it will extend your duration of studies, right? So you, for example, let's say you want to work as a researcher in the national lab, then you, or for example, you want to become a professor at university. So in that case, you need to go to grad school. You need to get a PhD. So basically, maybe in that case, you want to do 4 years and then go to grad school in the minimal amount of time. And as I said, I want to mention again that okay, if you do co-op, you have many opportunities with various industries, but also if you're just looking for research opportunities to understand how is to do research and to explore, then you can have that even if you're not in a co-op program through USRA, through the summer internship, or through the honors program. Okay, so there are many. I talked about industries for the co program, but yes, you can work for different agencies, government agencies. So, for example, there's a Metrology Institute, an NRC here in Ottawa. They're doing lots of interesting stuff. They're developing solid state devices for 3G technologies in the future. Lots of research, lots of high tech research and development they are doing. Okay, so this is about opportunities and how you see your future in the longer term. Now, let's say you start at Carleton. Just want to mention that there's lots of support. So first of all, each course, for each course, the instructors will have office hours. Okay, either they could be predetermined or they could be on demand. You just email the professor, and you can set up a meeting. The many courses have lab and tutorial sessions, and then you interact with TAs. You can talk to the TA or to the lab instructors or to the tutorial instructors. Our tutorials, the way they are structured, is, let's say, it's for about 3 hours per week, and the first 2 hours will be illustration of problem solving, which is an interactive session. You ask questions, and so you can customize. I mean, it's basically you can ask questions about your experience. You try some problems. You could know how to solve some aspects, or you got something wrong. Then you have an opportunity to talk to the teaching assistant and basically ask them and communicate to them, exchange, understand how to approach this type of problems. And the last part of the tutorial session is kind of an exam, a small test that based on the same type of problems that you try to solve in the tutorial. So this allows you to consolidate your understanding and learning. And there is also what we call a drop-in center. So this is one-to-one. So let's say if you need a little bit more assistance, I sometimes just the lectures, the office hours, the tutorials is not enough. You need to just sit down and talk to somebody. So this is done by a couple of professors, a couple of TAs, more advanced students like grad students. So in the drop-in center, you get an opportunity to sit with somebody and just say, okay, just to discuss a little bit about your understanding in the certain course, and maybe address some of the problems that really you find more difficult to understand, or something like that. So that's an opportunity, and there are like 3 or 4 sessions per week. Now, these drop-in centers are open to all courses. So basically, it's first and second year, including students that are coming from other departments that are doing a physics course. So our students in the physics department, but can be students for chemistry that is doing a physics course in the first year, and they have questions, things like that. As I said, for making future plans, it's possible and it's always advised to talk to the underground advisor. So this year, the underground advisor, it's Professor Kevin Graham. So basically, you just email him, and you can meet and discuss how you're going to take your courses. So if you're especially if you, for example, are not taking the full 5 courses per term, then you have to be careful with the prerequisites and understand a little bit how this can delay you if ever you're missing some elements. So the underground advisor can really talk to you about the characteristics of each stream, how to take your courses, how to moderate the load. So it depends on each student. Maybe some students prefer to go at a slower pace, but still, for example, keep full time, so take just 4 courses per term. Some other students like to recover during the summer, so they take less courses, but during the summer they take courses. So the underground advisor can explain to you which one are given during the summer, so what can be done and how to play on this. In terms of administration, Joanne Martin, she's our administrator, and she will, do everything, registration to courses and all these technical aspects of work in the physics department is done by Joanne, and she can help you with many such details. There is a handbook you can find on our website. It's written by one professor and with feedback from many other previous students. That's just uh, you know sharing the experience of previous students, how they survive the when they started at university, because the pace is different, it's very intense. There's lots of homeworks, lots of new things to learn, new people, new interactions, new way of doing things. So basically it's a nice piece of information that's it's helpful um, helpful advice. So if you want to read that, that's I think it's a good handbook. And there's the Science Student Success Center. It's another resource available. It's done by other students. So basically, it's older students that are more experienced. It's based on volunteers. So here it's broader. You can ask questions, but it's also like just to talk to somebody. How are they doing it? How is their experience? How they are adapting, and just learn many useful tricks. How is the first few years at university. Okay, so one more thing about requirements. So the threshold for admission depends on year. So it depends on number of number of candidates. But in general, I'll put it about 80%, maybe a little bit less, 78% average. Um, there are some requirements. So math, for example, advanced functions is required independently of which stream you're choosing. Calculus, if you go in one of those programs. Okay, so honors in the core program, experimental physics, applied physics, obviously math and physics. And then you also have to have one of the either the physics, it's recommended, but you can have just the science course. If you go to biology and chemistry combined, then you can have two sciences courses. Okay, no calculus. Um, and if you go for the major, you can have actually as well. I mean, yeah, like you just require math advanced functions, but you can. Okay, if you have physics, is better, but if not, you can have one of the sciences um, courses, and this is sufficient. Um, yes, so I think I'll stop here because I would like to see if you have questions, if I can ask anything that you might be um, wondering. There's a chat box. Oh,
If any folks have questions, you can use the Q&A feature on your screen and it'll publish a question and then we can answer them for you.
there is no video stream
No video stream, unfortunately, just the Q&A section on the right.
and no audio. So like
No.
no audio. Okay. And I'm trying to see who's attending. I cannot see that.
It looks like we have 5 people in the session right now. You can see it under the People in the Sessions tab on the right as well, right next to Conversations.
Here. Q&A. I got it. Okay. Don't be shy. I don't know if this will trigger. I hope the stream works, right?
You can also share the contact information for the department in the chats feature too, so that folks have it in case they want to ask some questions later.
Hi. Yes. I think writing to John is the best. She will redirect to any of us. So who's interested by Carleton? Are you guys thinking about other universities or? Hi. Cool. Do you have any idea, like more specific, what stream you would like to go into, or is just a general interest for now? Oh, okay. Okay. Are you applying to engineering? Okay. Are you interested to work in like for SpaceX or Blue Origin, one of those new companies? Physics engineer. Okay, yes. There's lots of activities right now in those fields. I think there's new people. I see there's more people. Maybe somebody has questions.
For any new folks who are joining us, you can use the chats feature or the Q&A section on the right-hand side of your screen to ask any questions, and we can answer them through video here. Otherwise, if nobody else has questions, there are some booths that you can go to if you want to talk to the departments a little bit more one-on-one. We have some faculty from the science department as well, or you folks can always reach out to us. Razvan just put the link for their contact information for physics in the chat section there. Awesome. I don't see any new questions coming in, so I'll hand it back over to you to wrap up the session because we've got about a minute left here. Any parting words for the students today?
Yes. Well, I mean, essentially we have a physics booth, so I will be there for the next 2 hours. So if you have questions or you just want to chat, yeah, pass by. I'll try to answer all your questions. And otherwise, I think we have another event later, like next term in winter. And yeah, I mean, if ever you have questions, from now to then, just please feel free to go on the website, and you can either write to Joanne, which she's the undergrad secretary, or you can write to me directly, and I'll answer your questions, or I can direct you toward some of my colleagues. If it's something very specific, like I don't know, medical physics, or I'm a particle physicist, so I will be able to answer questions related more with that field. But yeah, don't feel shy. We are very open, available, so we'll be glad to answer any of the questions you have.
Excellent. Well, thanks so much for joining, everyone. We hope to see some of you under the academics tab at some of our booths, and we hope you have a great rest of your day.
Thank you very much.
Take care.
Bye-bye.